My name is Steve Plum. I'm the senior editor of Automobility Daily. And if you're late arriving, let me reiterate Rick Klein's welcome and greeting, and thank you for coming to the event today. It's a pleasure for us to host this, and we hope it will be a long-running event in the future. We actually got started last night in announcing the first ever Automobility Awards. If you haven't heard, the winners were Google, Tesla, Continental, NVIDIA, and M-City. So congratulations to them, and good luck to everyone next year. They really laid down the gauntlet, and we're eager to see what's to come next. With such rapid advances, the auto industry is expected to change more in the next 5 years than the last 25, or perhaps even the last 50. But it won't happen automatically. It will take innovation and leadership, and a lot of that will come from people like yourselves here in this room. In fact, we couldn't be more excited about the lineup here today. They have outstanding bios, and I encourage you to read them in the program. Well, the purpose of today's event is not about to revel in the past accomplishments. It's about the future, the exchange of ideas and collaborating to turn them into reality. So the introductions for the speakers will be brief so we can get to the good stuff. And in the spirit of 5 levels of autonomous driving, we have 5 segments today. The first was the excellent keynote speech. And we culminate in a special interactive all hands on board Q&A involving speakers, moderators, and the audience. Don't miss it. While all the panel are exceptional, I tend to favor the first one, maybe because I'm the moderator, but I'm a little biased. But it's also the most diverse panel, with representatives from traditional suppliers, OEM, tech companies, academia, and R&D and testing. Up first is Chris Borroni-Bird, Vice President of Strategic Development for Qualcomm, where he leads the company's efforts in developing wireless systems for automated, connected, and electrified vehicles. Prior to this, Chris was GM's Director of Advanced Technology Concepts, which included the autonomy and high-wire architectures in the early 2000s that featured a lot of the enabling technologies for advanced driver assist systems. Chris also co-authored the seminal 2010 book, Reinventing the Automobile, which correctly forecasts much of what's happening today. At the time, it seemed way out there, a little bit futuristic, but as Chris has said, advances are happening so fast, it's even coming together faster than he expected. Please join me in welcoming Chris to the stage.
Thank you, Steve. It's a great pleasure for me to be here today. Can everybody hear me okay? Okay, thank you. So I'm going to talk today for about 10-15 minutes around a couple of emerging technologies that Qualcomm is developing that will support the drive towards automated, connected, and electrified vehicles. I don't know how much you know about Qualcomm, but Qualcomm is based in San Diego. It's a telecommunications company, but obviously we see a lot of convergence between the telecom industry and the auto industry moving forward. And a lot of the technologies that are in your smartphone have been developed by Qualcomm. And we see an opportunity to redirect or repurpose those same technologies and expertise into the emerging connected and automated and electrified vehicle space. Technologies like cellular communications, wireless charging, and so forth. So I show this slide to explain why there is no single silver bullet, as you can all imagine. We talk about connected vehicles, automated vehicles, electrified vehicles, shared vehicles, and certainly for urban mobility requirements, small footprint vehicles. Because none of these by themselves address all of the societal challenges facing the automobile, especially in an urban context, which is the most challenging. But we see a lot of synergies between them. And I want to focus primarily on connectivity and electrification in this presentation. So when we talk about connected vehicles, it means different things to different people. Some people think it's being able to bring content into the vehicle so you can stream media content, a Wi-Fi hotspot, for example. To other people, it means vehicle-to-vehicle communications. So this chart is really meant to show that in the past, up until now, as we think about connected vehicles, OnStar is a classic example of the features enabled by connected vehicles that have been historically the case. And right today, we see the emergence and the proliferation increasingly of 4G LTE connectivity in the vehicle, as well as Wi-Fi hotspot, to allow the user experience inside the vehicle to be enhanced. But in the future, as these items identify here show, it proliferates dramatically, and it changes. It becomes a far more integral piece of the car than it has been up until now. We think about the ability to crowdsource information between vehicles that could help improve safety and traffic management. We see the ability of connectivity to support automated driving, as well as to enable mobility on demand, because without connectivity, none of us would be able to use Uber, for example. So at Qualcomm, we're developing all the different types of connectivity that are required for the vehicle in the future. And that ranges from inside the vehicle and the development of power line communications, where we can eliminate wiring, to in Bluetooth and Wi-Fi for the cabin experience. Also increasingly with the cloud connectivity, 3G, 4G LTE in the future, and we're working aggressively on 5G, which will provide tremendous improvements in terms of bandwidth and coverage and latency. GNSS, which is here we would call it GPS, is also increasingly important, and we're the main provider of that technology for automotive applications. And then, as we talk about vehicle-to-vehicle communications, or V2X in general, where X could be the pedestrian, a cyclist, a traffic light, a parking structure, and another vehicle. We're working on DSRC. We provide DSRC chipsets, but we're also looking at cellular variants of V2X, which can have a longer evolution path than DSRC, perhaps. So with respect to connectivity and vehicle-to-pedestrian communications, Qualcomm is somewhat uniquely positioned because we supply connectivity to the vehicle and to the phone. If you have a smartphone, and I assume pretty much everybody here does have a smartphone, it likely uses a Qualcomm chipset in there for providing the connectivity. And many of them also have our processor in there for the compute platform. But we're able to provide the ability for vehicles to communicate to phones, and that can provide potentially some interesting safety benefits in urban environments. As you may know, about half of the fatalities on the road worldwide are vulnerable road users, people outside the car, and that percentage is much higher in the emerging markets than it is here in the US. But it's a huge number of people at risk on the roads who are walking or cycling. And potentially, this is still a concept really, but potentially you could imagine people carrying a phone, or it might be a cell chip, a chip inside the bicycle helmet or in the frame of the bicycle itself, could communicate its position and speed and trajectory to oncoming vehicles. And those oncoming vehicles might be able to take preventive measures before actually seeing the pedestrian or the cyclist. So I have a short video here, which we demonstrated a couple of years back in collaboration with Honda. In fact, we have this vehicle at the Next Energy facility in downtown Detroit, where we have a laboratory. I'll just show you this 2-minute video. With this demonstration, what we are going to be showing you is the vehicle is currently set to be in reverse, so you see the backup camera display. So the backup camera is seeing out behind the vehicle because the vehicle is put into reverse. It can't see any pedestrian at this point. We'll have a pedestrian carrying a smartphone walking towards the vehicle. He is transmitting information to the vehicle and receiving information back, such as speed and relative orientation. And when he gets too close, you will see a warning both at the vehicle side and on the pedestrian's smartphone. This is the image you see on the head unit that the driver sees. He gets an alert that there's a pedestrian approaching from the left-hand side of the car. And the pedestrian also on the smartphone is getting a warning. So both the driver and the pedestrian are warned, and hopefully the collision can be averted. So in the future, vehicles with all these sensor technologies can also have connectivity and anticipate a collision even before the vehicle sensors see the collision is imminent. Now, clearly, there's still a lot of challenges left to making that happen. As you can imagine, in a dense urban intersection where lots of people are transmitting information, you could have challenges with channel congestion on the phone. And then the accuracy of positioning is paramount. You don't want to be transmitting information all the time, because then you're going to be draining your battery, and that's obviously not desirable for people using a smartphone. So there may be solutions to that in terms of contextual awareness, so it only turns on when you're outside, or maybe even more precisely when you're about to cross a street. But there's still quite a lot of development work needed to make that truly robust. And the embodiment shown there is a little bit misleading. It was meant to show the concept in an easy-to-understand form, but in implementation, we would expect that it would be invisible or transparent to the user. Basically, the pedestrian wouldn't be looking down at his phone crossing the street, because that might cause an accident to happen. So we wouldn't be necessarily receiving information on the phone side. It'd be more about transmitting information to the car and to the car's compute platform, not necessarily to a display unit. And the compute platform in the car would integrate all of the sensor information as well as this connectivity information and make a more robust decision. This chart really just shows, we've talked about sensor fusion, and that's a well understood and agreed upon concept. But I would also argue we need connectivity fusion, and even more broadly, connectivity and sensor fusion. The challenges of facing autonomous vehicles are so profound and high that we need every single support we can muster to really make the solution as robust as possible. And I would contend that the combination of connectivity and sensing is far more powerful than just relying on sensors alone. And as we look at connectivity, it's not simply vehicle-to-vehicle communications. It's vehicle to cloud, back to vehicle, vehicle to infrastructure. It's vehicle to other people on the roads. And as you can understand, connectivity can overcome some of the challenges that sensors face in adverse weather conditions, or seeing through obstacles or around corners. So connectivity by itself is not the solution, but I would also argue that sensor fusion by itself is going to still create a very challenging environment, and with the aid of connectivity, we can provide a much more robust solution. On the electrification side, I mentioned briefly power line communications. This is basically the idea that when you're plugging in your electric vehicle, instead of having a separate line for communications, you would integrate it with the power line. So communications would be flowing along the same cable as the power. And that, if you translate that concept to on the vehicle, there's potential to save a lot of wiring. As you can imagine, the wiring harnesses on cars today are extremely complex, and most of the wires are actually providing communications rather than power. And so if you can eliminate a lot of those communications lines, you could simplify the wiring assembly and design. But our primary interest at Qualcomm on the electrification space is around wireless charging, which we think has received a lot of benefit and increased interest recently because of the emergence of autonomous vehicles. So if an autonomous electric vehicle, perhaps shared, but not necessarily having to be shared, but it could be a private vehicle, is parked automatically, we think that wireless charging is a very natural fit for that. And in principle, you could imagine in the future wirelessly charged vehicles frequently topping up during the day whenever they go off and park. So if you imagine a robo-taxi application where the vehicle drops somebody off, goes back and sips a bit of power quickly before it picks up the next passenger or the next customer. We think that you could get by potentially with smaller batteries and make the vehicles more efficient and lower cost, and still provide the level of service that's needed for mass adoption. So the challenges associated with electric vehicles are well understood, although tremendous progress is being made on the cost front and the range front, as you know from some of the introductions of vehicles like the Chevrolet Bolt and the Tesla Model 3 and so forth are going to address some of these challenges. But still, the uptake of electric vehicles, we feel, will be enhanced significantly with wireless charging. And the idea here is a little bit like Wi-Fi. You want to be able to pick up charge routinely throughout the day rather than just once at night with a big amount of energy consumption at nighttime. We want to be able to pick and choose when you pick up power. And so the idea of parking spaces that you park on and automatically charge, There's quite some data anecdotally as well as some studies that show that people who drive plug-in hybrid electric vehicles don't always plug in. You can imagine if you drop a vehicle off and you're making a short trip into a store for a few minutes, you may not bother to plug it in. And in that case, you end up running on the internal combustion engine vehicle more than might be expected, considering it's a plug-in hybrid. Whereas if it was wirelessly charged, it would be using more electricity and presumably helping the environment more. So wireless charging could be better for the environment, potentially. The technology that Qualcomm has developed and that we license to Tier 1 suppliers is capable of providing high power. We've demonstrated 3.7, 7.4, and now we're working on 11 and 22 kilowatts. It's extremely simple to use. We think that customers inherently value convenience. And once you experience wireless charging, you really won't want to go back to having to plug in. One of the concerns that people have clearly is it safe? We all know from the early introduction of cell phones that there were concerns with electromagnetic radiation being close to your ear. And so we had to address those issues at Qualcomm by developing tools and expertise to really understand electromagnetic radiation, and we're applying the same expertise and people to this challenge as well. The idea being that you should be able to walk by this vehicle while it's charging and not have to worry about any stray radiated fields. You should be able to sit in the vehicle while it's charging. You should be able to have a pacemaker and not have to worry about it. You shouldn't have to worry if your cat goes underneath the car and sits on the pad and being exposed to electromagnetic radiation. All of these challenges need to be taken off the table, and we're working on that. So I want to show another short video that shows how this technology works. Oops, can I go back? Is it possible to go back? Ah, here we are. No. Can somebody play the video? Thank you.
Hi, I'm John Curry with Qualcomm. Today we'll be demonstrating our Qualcomm Halo technology for wireless charging. We'll also demonstrate our pedestrian accident avoidance technology. If you're familiar with electric car charging today, you know that you have to plug the car in and wait for it to charge. Well, in the future, this will be automatic. All you do is roll the car over a charging pad and the vehicle will begin charging automatically. So we can demonstrate that here today. We have a charging pad on the ground. We have a driver that's going to drive that vehicle right over the charging pad, and you'll see an alignment circle fill up and show that he's aligned over the pad. When he's fully aligned, he stops the car and he starts the charging process. So this car will charge completely wirelessly, completely automatically at the same rate as conductive charging. In our case, this is about 3.3 kilowatts of charge. On the screen here in a few moments, you'll see the car come up to speed at charging rate at 3.3 kilowatts. All right, the vehicle is charging at 3.3 kilowatts now, the same rate as a conductive charger. Now, people often ask me, what about my family cat? What if the cat crawls underneath the vehicle while the vehicle's charging? Is that okay? Well, we have a safety system just for that occasion. We call it living object protection. I'm going to demonstrate that now. As I walk over to the vehicle, I'll pretend that I'm going under the vehicle and the system will shut off. So as you see, the living object protection system detected that I was attempting to get under the vehicle and shut all the power off, so it's a safe system. And next we'll be
So I should point out that with this technology, we have a different business model than the traditional technology supplier in the auto industry. Coming from outside the auto industry, that may not be so surprising, but our vision is to license the technology, the underlying technology around the magnetics and the living object protection and some of the other ancillaries for positioning and so forth. We developed that and with the idea of licensing it to a wide variety of Tier 1 suppliers who would then add their own secret sauce in terms of power electronics or thermal management or packaging and so forth, and then supply to the car makers. We think that this model is quite interesting for the auto industry because not every tier one supplier has the capability to really develop from scratch the magnetics or the fundamental technology that makes electromagnetic wireless charging viable. But we still want to create a very diverse and competitive supply base for the auto industry. And so by developing this basic technology and then licensing it to the tier ones, we think we foster a lot of competition and diversity of supply for the auto companies that wouldn't necessarily exist otherwise. It's a similar model that we have in the handset business where we supply lots of technology to the different smartphone makers. And finally, I just want to wrap up. This is our vision of the future for wireless charging. The static wireless charging or wireless electric vehicle charging would take place on pads in parking spaces, perhaps in home first and then moving to public parking spaces. And then ultimately we are looking at semi-dynamic wireless charging, which might make sense for like taxi ranks, where the taxis are inching forward at a slow speed and can charge wirelessly, or at approaches to intersections where vehicles slow down and potentially stop for a few seconds. And then ultimately, even dynamic wireless charging, where you might have a dedicated lane. This would only make sense really if you have a lot of traffic that is wirelessly charged capable, so that you get the economies of scale to justify the investment on the infrastructure side. And then finally, again, our vision of the future for mobility in an urban context in particular is the convergence of all of these wireless technologies around communications and electric power transfer with the automobile and the smart city environment. So thank you.
Thanks, Chris. Our next speaker is Andy Smart. Andy is not only an expert in the technology behind autonomous vehicles, he also knows what it takes to test, validate, and standardize the systems. After stints as a consultant and in various OEM leadership roles, and most recently as Chief Technology Officer of SAE, Andy was named CTO for the American Center for Mobility earlier this year. At ACT, he's tasked with converting a 332-acre site, which at one time had been a GM powertrain plant, into a real-world proving grounds for autonomous vehicle technologies. If you haven't heard about it, you will a lot in the future. He's also working with industry partners to develop technical standards for autonomous vehicles. Please join me in welcoming Andy to the stage.
Thank you very much indeed, Steve. So as we go through this morning, really leading on from what Chris was saying in terms of all the connectivity between the different devices and the ecosystem as it is at the moment. There's testing involved, regulation, but also the key validation aspects as well. So that's really what I'll try and cover with you this morning. I won't play the video here because it really gets the hairs in the back of my neck up, but it really just shows why we need this type of technology. This is on I-94 some months ago here in snow, basically a pileup of traffic. And when you watch the video, it's not very pleasant at all because the vehicles just keep piling into one another. And it just goes to show if they had certain levels of connectivity between one another, this could have been avoided. But when we look at it in terms of where we are in terms of the technology, really it is and will further revolutionize what we see as overall transportation and mobility as regards to safety, mobility, and overall energy use as we see it. But there are many challenges ahead, as John Leonard described in terms of where we are in research, certainly in product development, but it's not only from the technical point of view, but also the policy elements as well in terms of where we are from a regulatory point of view. But really the overall concerns we have relate also how our standards are being developed within this community and the speed that the standards are being developed with regards to the overall testing, validation, and verification as well. So from our perspective, it's a combination. From a simulation point of view, on-road, track testing, all will be required as we really reach that point of overall validation for the technology. But what are the overall needs as far as we see it at the moment? As I said, the overall acceleration of the development of the voluntary standards, absolutely key. But then it's how we go through the overall validation of this technology as well. And that also to ensure that really it's safe to deploy on the road network and within the buying public. But then when we go through here, as Chris was relating to as well, is you look at all the connectivity of it all. And when you're looking at the standards relating to vehicle to vehicle, vehicle to infrastructure, and then different parts of infrastructure to one another, and even, as Chris showed, cyclists to your smartphone. So it really is the overall evolution of the Internet of Things where all of these parts will be then connected. But then when we look at the overall requirement in terms of testing and product development, as you can see the overall listing there, that's just a short list. When you look at the overall requirements here, you know, anything that, you look at the cyber element to it, you look at how the different types of communication, we mentioned here DSRC, but also, as Chris was pointing out, currently 3G, then moving into 4G and 5G. But then the different road surfaces. You know, as we know in Michigan, we have a number of rural road surfaces in terms of unmade roads. How do we navigate through these when we have no really defined road surfaces, markings? We have ditches, we have trees, we have animals, we have many, many different things. So how do we take all of these into account? But I think really at the bottom of that is when we get to sort of international harmonization, which is the absolute. This is absolutely key as well. Only a few years ago, you could actually take your phone from the US and actually use it in Europe and other parts of the world. That's a key part of it. When we look at the vehicle technology as well, when it comes to the comms, communications side, that has to be really seen from a global point of view. When we look at the overall drivers, yes, you can go through the overall pestle analysis, but I'll save you the trouble and just say it really boils down to two buckets. The overall drivers are efficiency and safety. The safety one is harrowing. 2015 numbers up 8-9%. Absolutely not acceptable. You look at the 2016 numbers, they're up again. Up again. If we go through and you go through the driving in Michigan, you'll see the number of fatalities so far this year. They're up, what, 705? So we're looking at, what, 35,092. One every 15 minutes, 4 an hour, 737 a week. It's harrowing. And when we look at this, you look at what brought us to this particular point, and we look at, and this is an improvement, if we look at the overall statistics, 1.12 fatalities per 100 million miles driven. Number of miles driven is increasing. The statistics have come down. When it first started, it was around about 7, and now we're down to 1.12, so it's very good progress. And what brought us to that point, if we look at the body structures, seat belts, etc., these are key technologies that have helped. But when you look at the statistics, and I've gone through it so many times, and then you just have to stop and say, well, if 7,000 people had been wearing seat belts, that number would be lower. So there's some fundamental things when it came to, when John was talking about driver training, that's still a key element, even for the fundamentals. When we look at how we're going to get from the 1.12 or the 35,000 and reduce that, this is again the very, very short list of what's involved in all of these things. And with all this point that it comes to the product development, the testing, and the validation of all of these things. And the technology involved is going up at such an alarming rate. When you look at this part of it, and you say, well, where are all the statistics involved, then a lot of it then looks at distracted driving. There was, I can only describe as a frightening interview I saw when it said the role of the passenger is now very important. Why is that? It tells the driver when to look up. Yes, that's right. And that was frightening in itself. So not only are we looking at customer training, the other element we require is here's the driver training, driver education. What is required to this? So no matter what technology you have on board, the driver is a key element to it, especially in level 2 and 3. 4 and 5, not so. But we still have to say we have to go through increased driver training in these elements. So you look at the predictions. Everyone's asked, when is it going to be there? Between 2019 and 2021, according to the sort of major voices in the industry. Then you look at another view, and then you say maybe it's not so much John Leonard and what was on Reddit, but Steve Schladover at UC Berkeley, he just thinks we'll be underwhelmed. But if we look at the level of technology and validation and the safety requirements to get this into full production, this may well be the case. But I think when you look at it, the hype has got really totally out of sync with reality. I think a lot of us may agree with that. I do. You look at the different Gartner hype cycles. This is always very interesting, especially when you get to the peak of inflated expectation. And that's exactly last year where autonomous vehicles were. That's where they were. If you look at where we are now, we've dropped off the peak a little. That may be because of the fatalities reported recently with Tesla vehicles. And then when more, that to me was good to report, but I was just wondering who was reporting the other 99 deaths that happened that day. Really, this was the only important one. And again, you've got to have some respect for human life. But we really have to be clear what's peaked. And again, we're talking what's in a name. They called it that. You look at other technologies, other manufacturers, we've got different names. But what we don't want to get into a particular point is there's confusion even on what we call it. So again, not only in the standards process, definition is always a very important starting point. This relates to front crash protection. So if you went into a dealership and you wanted to buy, as you say here, an Acura, or a Buick, or a Jeep, or a Mercedes, all very different things. So if we don't know what we're calling it, and we don't know what the customer's buying, no wonder we're in a little bit of a confused state. The good news is, from an overall guideline point of view, it's been a long time coming. I think within the industry, we've been looking to NHTSA to issue out standards, as we thought. But I think quite cleverly, really because of the pace of technology, guidelines were really introduced and overall frameworks, which really I think is more appropriate to how the advancement of technology at the moment. And especially when you look at the moment, looking at public comment at the moment, so we're still during that phase, and we know a number of comments are coming in, but I'd just like to draw your attention to the bottom there. Really from where I'm standing at the moment, this was very critical to it all, was then when you're looking at certain testing and validation, variable test procedures, but really more real-world environments. And that is what we see as critical. We saw also when John showed you a picture of sunlight. Yes. That happens out there. That's realistic. We know ourselves. And if I would challenge each of you in driving home later today is to do something that I learned when I was going through police driver training. A driver commentary. Comment on everything that you see in front of you. And when you start doing that on a regular basis, you realize what the sensors will have to see. And then what will have to happen therefore. What do you see in the future? What do you see over the hill? What do you see around the corner? What don't you see? What are you predicting? All of these things. It's just a humanistic thing to do, but that will give you a better idea of what the sensors, the work they have to do. If you look at what's happening here more locally, you look at latest Michigan legislation, where we'll be here at the moment, hopefully within end of November, when reconvene, the legislation will be approved in terms of the overall testing on Michigan roads, which we think is a very positive thing and really will then complement the other work that's going on within the area. And also, as we look here, the American Center for Mobility was then named in this in terms of what we're working on at the moment. And we felt that was extremely positive as well. But not only on the vehicle side, if you look at then what's happening on the roadway, when you look at these 4 goals from Federal Highway, to me, this becomes maybe relatively simplistic, but it's actually extremely important. You look at those 4 things. 1, looking at V2I at an intersection. If you go through all the studies, this is one of the major incident areas. Number 2, end of queue warnings. We saw that in I-94. If you see a queue coming up and it's invisible to the naked eye, but the car should see it, that will actually help you, again, from a safety perspective. And then looking at work zone management. what things happening. We all know we come up to temporary work zones. What happens? You see, I saw it recently on some rural roads. Again, if you had further advanced warning, it will just enhance the capability and actually increase safety. And then finally, curve warnings. Sometimes in the matrix system we have here, in US roads, that maybe not so much required, but many, many parts of the US, you have curved roads, and again, what's over the hill and what's around the corner. So when we look at the vehicle connectivity side, the statistics, again, what is happening, again, the acceleration of it all. If we looked at the AT&T report back in July, over 2 million new wireless lines, absolutely excellent. But when you said almost half of them were cars, then you're saying, well, really the market for the smartphone is there, but the market then for the car connectivity is then where the money is, because that's where the acceleration is. And then we look at the number of new cars which are then going to be connected. Again, the statistics, the answer is just more. Because again, if you ask yourself the question, when did you ever see your cell phone bill go down? You look at then the total vehicle trends, which is what's happening. You've got 255 million vehicles in the park in the US. Again, it's going with 16 million vehicles sold per year. It's going to take some time to then bring this new technology into the park. One of the things, and John, with regards to SEMA, this is really from yourself, it relates to aftermarket products. They could then accelerate vehicle connectivity and the safety technologies. To me, this is an absolute key area. So what's happening that regards ACM, Centre for Mobility? We saw the opportunity in terms of the validation of the technology. 2004, we mentioned the DARPA challenge. The technology really was developed here in the US. We want to maintain that. We see the overall competitiveness around the world for this. But also we saw, bring it down to a micro level, the community around Ypsilanti, very hard hit in terms of industry. And then what we had was very much an ideal situation. When we look at why this location was chosen, you look at Michigan, where we are at the moment, the density in terms of supply community, OEs, very progressive Department of Transportation. Kirk Steudle, great respect to the gentleman in terms of what he and his team have done as regards connectivity on the roadways. And then when you look at that linked to the academic resources we have in Michigan, absolutely tremendous. So where we are at the moment is we're developed as a not-for-profit testing and product development facility, clearly for the validation of the standards, but validation of the technology, but very much the acceleration of the standards. So where we are at the moment is many letters of support from industry, academia, and government agency, initial funding from Michigan Strategic Fund. Really, the process is in place in terms of purchasing the land, and then we're then working on the overall design at the moment with our partners. So I thank them all very much. But where are we? We have a current state at the moment. If you look at this from a bird's eye view, you go, wow, that is an opportunity, isn't it? But what you have here is on the west of the airfield, we have really the key transportation elements. To the top left, you have the main Detroit to Chicago rail line. We have a rail spur coming into the site. To the east of that, you have Willow Run Airport. So therefore, what we have there in terms of air transportation. And then the proving ground in the middle. So very much we have planes, trains, and automobiles. If you look at then M-City, which there's a lot of conversation, from M-City point of view, absolutely leading edge for the technology for R&D and academic research, where we have, as was mentioned, with about 332 acres, really much larger than that from a product development point of view. But then, so where we are at the moment, we mentioned real test environments. I'd love to show you what's going on inside, but you'll have to wait a few months for that, because we're very much, when we look at an overall global perspective, people are developing this technology and these testing environments very quickly, so we have to be very careful here. But what I can say is the test environments will be representative of the real world environments, and especially when you just take two elements there. The current US 12, where we have at the moment, will actually be repurposed for the use for the facility. So we have very much part of a real world environment, part of a 2.5 mile loop, which will be there. So really where we see at the moment in terms of testing and validation, centered very much here in Southeast Michigan. Look forward to certain questions you have. Thank you very much.
Thanks, Andy. Next up is Carla Bailo. Following a distinguished career at General Motors and Nissan, where she rose to become the head of R&D for the company's Americas operations, Carla left the corporate world to go back to school. Now, some of you may not agree with the school that she chose, but she did so for good reason, and she's making a true difference there. 2 years ago, she joined Ohio State University, where they created a new position for her as Vice President of Mobility Research and Development. Her focus is on improving people's lives through innovative transportation systems. You know, as Andy noted, safety is a big part of that, but she's also working on improving mobility for the elderly and disabled. To this end, she helped Columbus, Ohio win the Smart City Challenge and is working with the city to implement and test new technologies and services. Please give a warm Michigan welcome to Carla.
Good morning. I realize I'm the first speaker in this panel that really has a true Michigan accent. And you can imagine how challenging that is to be in Columbus. Also, to be a Michigan grad living in Columbus is extremely challenging and a lot of fun this year, finally. So I'm an engineer by degree. Let me advance this somehow. Whoop. Now I've gone too far. Okay, there we go. I'm an engineer by degree. We've heard a lot about a lot of the technology, and I could probably talk about that all day. But being in the automotive industry for as long as I was, and my last 25 years were in Nissan, we really were focusing on active safety and focusing on artificial intelligence. In fact, we opened the Silicon Valley office really focusing on artificial intelligence. But I was asked to come into academia and really take a look at all of the different pillars in research going on in mobility, everything from exoskeletal up through drones, and really see what we could work on holistically as a university, because fundamentally, this new era of mobility is really going to require a holistic solution. We can't do it with technology alone. So really taking a look at everything that was existing and anything that moves people or goods. And with that, then, let me first start with defining what we say is mobility, what is smart mobility, and then what are some of the items that have been launched in the university and then leading into the Smart City Challenge. So mobility is the movement of people and goods. We know that, from place to place, job to job, but more importantly, it's a way to move from one social level to another. And we have bridges that exist. Some are physical, some are actually built purposefully to keep neighborhoods segregated from others. And some are really assumed, but offering people mobility can change their lives. So what is smart mobility? It's really the movement of people and goods with what I coin as the 000, which is 0 accidents and fatalities. You heard the numbers from the previous speaker, from Andy. We're not getting any better, and 94% of those fatalities are caused by human error. So we need to stop killing ourselves in our cars. Secondly, 0 carbon footprint. And lastly, 0 stress. And 0 stress is for the driver, the passengers, and for the vulnerable road users as well. So knowing our capabilities within the university, I launched initially last July the Columbus Smart Mobility Initiative. And that starts with a contained test bed, and I know you can't see that up there. We have our own proving ground. It's one of our best kept secrets, I think, in the state of Ohio. It's called Transportation Research Center. It's 4,500 acres. In this facility, we can test any kind of transportation, all the way from ATVs up through drones. We have FAA certification to do drone testing. We can see what's going to happen when we have agricultural equipment transmitting data, drones transmitting data, cars, semi-trucks, anything else transmitting data in a contained space, and see how they're going to interact. Similarly, on the south side of town, we're building another very small research center. It's only 47 acres, mainly focused on city research. And both of these pins surround the university. And then we also have the opportunity, fortunately through great collaboration within the city and within the surrounding areas, we now have a 35-mile stretch of completely automated connected vehicle technology and research. The cities that surround the area plus the county agreed to put in $5 million for the fiber. And just last Friday, we were awarded another grant from the federal government to be able to put in the remaining infrastructure, partnering with Battelle and some of the others that are in the area of Columbus to make this happen. So 2 great contained test beds and then a way to get out and test as well. So all the research that's happening in the university can be done in these facilities. Secondly, we've heard a lot about collaboration, and I think it's vital because all the universities are doing work, MIT, Ohio State, University of Michigan, Carnegie Mellon, but really it's going to be the banding of that knowledge, much as we do in industry, to make sure that those core competencies that we lack, that we bind with others who have those core competencies, get rid of the not invented here syndrome, and really collaborate. And this is the smart mobility collaboration, and we're still, as a group, trying to decide if that's really going to be the name. But it's combining the resources from academia of Carnegie Mellon, the University of Michigan, Ohio State, and now I'm happy to say that Kettering University in Flint is also included in this, with the departments of transportations of the 3 states, along with the Ohio Turnpike and the Pennsylvania Turnpike, to really create an area to do testing for goods and freight movement. And we believe this kind of core collaboration will really make the breakthroughs that we need. We have the unique ability here of differences in terrain, differences in environment. We have the snow, the rain, all elements that the autonomous and connected products have trouble. And we also have the ability of toll roads, border crossings. I'm not sure yet how we're going to have an autonomous vehicle show its passport, but we're going to have to figure this out. And that's the kind of research and collaboration we're putting together by this tri-state corridor. Eventually, we'd like to take it all the way out to New York City and into Chicago, which is the main route of goods coming in from the East Coast. And considering what's happening with e-commerce and the boom in the number of goods that are going to be shipped and have to be shipped immediately, this is going to be vital to solving those issues. So one of the things, when I was talking about all these great corridors that I wanted to put in, somebody rightfully said, "That's really great, Carla. I'm so glad you want to do all these great technological, geeky things. But really, what does it mean? When you're going to ask the Science Foundation for funding or somebody in the government for funding, what's the benefit to society?" So I mentioned the 3 zeros, and let me elaborate what those mean. So first, we've already heard saving lives. We know we're killing ourselves on our roads. But not only preventing the accidents, but what can we do quickly when there is an accident? We can send drones out. We can send them to go see what happens, start rerouting traffic, get the right equipment there sooner. Or even in a case like this, where somebody has had a problem, maybe it's in a venue where emergency equipment can't get there quickly, we can send a drone in with EpiPens or with defibrillators, whatever this person may need who has the problem. Secondly, we know that about one of the fastest growing age segments is 65 plus. Some of us are closer to it than others. And in this age group, more and more people will be losing their independence or will become disabled. And this is a product called Kenguru. It's a small EV that is not autonomous yet, but could be. And a person who is disabled can simply enter into the vehicle, seatbelt themselves in, and operates just like a motorcycle. It doesn't go over 35 miles an hour, but it does allow them to get to where they need to go and to have independence that maybe they have lost. And we keep hearing about the people who are really concerned about autonomous drivers, 70% fear them. But I think we really have to think about those people who have never had that independence ever, and or those who have lost it, because I think if you were to ask them, that percentage would be so much greater in terms of acceptance. When we think about urbanization, super cities, mega cities, 30 million people, 70 to 100 million people in some cities in China, being able to keep all of the road users safe are vital. And I would challenge that we need to think about a whole different way of planning our cities. Right now, when we plan a city, what comes first? The roads. The roads come first. We think about transportation and getting people in and out by vehicles. But what we need to do is plan our cities based on the health and the environment that the citizens want, and then think about the transportation solutions that we should offer. Parking lots can go away, more green spaces, more walking spaces, happier, healthier people. Environmental sustainability, this is pretty clear. Not only the products that we drive, but the grid itself needs to be cleaned. Just to give you an idea, in Columbus today, because the vast majority of our power comes from coal, even if I drive an EV, I have a larger carbon footprint than if I drive a very efficient ICE. And lastly, economic sustainability. This is so important from an academic standpoint because we're hearing about jobs that are going to be lost, but every time we've gone through a disruption of this nature, we always have been able to find other opportunities and other ways to retrain our workforce. But with technology so quickly coming, and with the growth rate of technology, we also need to think about continuous education in our workplaces to keep our employees relevant. So what's a smart city? It's the deployment of technology and data to improve people's lives. That's so important. Otherwise, you're just throwing technology and data out into your city for technology and data's sake. So the Columbus Smart City Challenge, let me give you a little bit of background. It was actually launched in December. I had launched the Smart Mobility Initiatives in July. So some of the figures are there: 40 million from DOT, 10 million from Vulcan, which is Paul Allen's foundation for EV and electrification. And we were able to garner another 70 million from Columbus. So in totality, we now have 140 million to do the pilot deployments. And it was all about using technology to reduce congestion, give access to all, or provide the ladders of opportunity, and improve the environment. So very much aligned with some of the work that I had already started in July. That, of course, is why I jumped all over this and called the city and started the wheels moving to be able to make this proposal. It was a very short window. We had 2 months to put together a 30-page proposal, and then once we were a finalist out of the 78 cities that applied, we had basically 2 months to then go ahead and write a 130-page proposal for both Vulcan and DOT. So Columbus is actually the 15th largest city in the States. I was shocked when I learned that. But we have about 1.2 million people between downtown and in the perimeter. And by 2050, we knew we were going to get about another 500,000 people. Now that number now is more 1 million at the rate that we're growing. And we really took a look at how we were going to handle that growth and what issues we were going to see, and sought to solve those gaps when we put our application in for the Smart City Challenge. And it's all about access for all, providing data for all, options for all. And it's really narrowed into certain districts, starting with access to jobs. We're putting in a bus rapid transit line. We have no public transit except buses in Columbus. So bus rapid transit line, plus we're putting in some autonomous shuttles. They're going to go from one of the most congested areas that people come in and out of for work. And we'll have autonomous shuttles within the complex, but also going from the public transit into their office environments. Smart logistics, we have the 10th largest inland port in the nation as well, doing low-speed platooning, communicating with traffic signals to make sure that the trucks are on the routes that make the most amount of sense and that they don't miss their delivery windows. Also doing smarter unloading and loading in congested city areas. The third area is connected citizens. We have an area that's really a mobility food desert. It's about 3 miles from the university. It has 4 times the rate of infant mortality of the national average. Also, if you're born there, you have less than a 20% chance of actually improving your social status. So putting in Wi-Fi hotspots, putting in sidewalk lab kiosks, providing first mile, last mile solutions so that access to jobs, access to medical care can happen. But again, throwing the technology in this community isn't going to solve the issue. It's going to require a lot of community outreach, a lot of discussions, training, and understanding. We have huge bottlenecks that happen when we have events, so providing real-time information, real-time parking information, which at this stage, when it comes to a Buckeye football game, all it's going to tell you is everything is red and there's no parking available. So after that, we're going to have to really think about transit hubs and getting people in and out more smartly, and sustainable transportation, increasing our EV usage significantly and cleaning up our grid with a combination with American Electric Power. So in a nutshell, that's the Smart City Challenge. I've got a great video that I'm going to show now. It's going to take me a couple minutes overtime, so bear with me. But this really shows clearly, in very simplified and graphic form, what we're doing in Columbus. So let me just end with one comment. Since we won this award, when we say we're from Columbus, we don't have to add Ohio anymore. Thanks so much.
Thanks, Carla. It's now my pleasure to introduce Jeff Klei, President of Continental Automotive North America. After joining Continental 18 years ago via the company's acquisition of ITT brake and chassis unit, Jeff has held nearly every single senior executive position at Conti. And he's been instrumental in leading the company's growth and transformation over the years. A mechanical engineer by trade, Jeff now is leading the charge when it comes to automation and intelligent transportation. I was lucky enough to experience some of Conti's latest innovations firsthand at their test track in the UP recently. It's pretty exciting stuff. Please give a welcome to Jeff.
Thanks, Steve, very much. And here we go. Thanks for the great introduction. I really appreciate it. It is a pleasure to be here. And by the way, Carla, great video. Continental's really happy to be part of that Smart City Challenge. We've committed about $1 million initially because we have the same vision as Carla and as Vision Zero, and you'll hear a little bit more about that. So it's a great honor to be here, to participate in the panel, and to really look at the way Continental sees the future of mobility and really kind of reinventing or reimagining transportation. We at Continental think in the past, it was really the car that changed the world. It provided safe, comfortable, reliable transportation of people and goods and enabled mobility around the world that, quite frankly, no one really knew was possible. But we believe in the future that it's really the world that will change the car. And the world is changing, which is really motivating all of us to really look at the way we transport people and goods. And if you think about the mega trends and the mega factors that are driving that transformation, there's three main factors. Number one is urbanization, and it was mentioned in a few of the presentations as well, that urbanization is one of the big motivators. If you look at in 1950, 30% of the world's population lived in urban environments. By 2050, 70% will live in these urban environments. And with that comes congestion. It comes the mega cities that we talked about, and it really drives a significant change in the way we have to think about transportation in these cities. You're already starting to see the push more towards electrification, but we think with autonomous driving that will also help enable safer, more comfortable driving and less congestion around those cities. The second factor really is the factor of technology. And if you think of technology, it's really in processing power, it's in sensors, it's in the entire automobile, but also the technology around the vehicle. And it's also coming down in price. And the final factor really is digitalization. And we're not talking about just digitalization in the car, but digitalization around the car, the entire ecosystem. And the smart cities that you begin to hear more and more about are a big test bed for what that can do. So it's those kind of mega trends, if you will, that are really driving the change, and what we would say is the world is now changing the car. One of those big changes we think is automated driving. You'll notice I don't use the word autonomous too often because we look at more driving as automated driving. Autonomous is quite a ways off, and we think automated driving is really the step-by-step approach that's needed. So what is our motivation for automated driving? It's really four factors. The first is safety, and by far safety is the most important. If we don't do it safely, we will never, as an industry and as a world, be successful with automated driving. So safety is by far the most important. And you saw some of the statistics before, that today, 3,000 people each day on the world's highways die. Another 140,000 are injured. That's not acceptable. And what you also saw earlier is the numbers are increasing. There was more than a 10% increase in fatalities on the US highways in the first half of 16 versus the first half of 15. Distracted driving is clearly a main motivation there, or a main driver there. Okay, you could say, well, there's more miles driven, but the fact is it's only 3% more miles driven. So a huge problem, and that's now 2 years in a row. So we have to find a way to reduce the distracted driving fatalities and enable safety in the vehicle. Despite the increases in fatalities and the no texting laws, it still isn't successful enough. The second is efficiency. If you think of these mega cities and you think of the congestion, we think it's obviously fuel economy, but it's also improved traffic flow that will increase the efficiency of mobility around these cities. The third is comfort. Who wouldn't want to arrive at their destination more rested, less stressed, more comfortable, and more ready to take on the challenges of the day, especially when you think of the commute times averaging about 35 minutes each way each day, and people spending about 110 minutes a day in their car. There's much better things we can do, really, and that drives a fourth one, with the time that we have in the car. And this motivation to really spend more time in the car is going to become a possibility to look at different ways to use your time. Services, more business models to bring content into and out of the vehicle will be a main motivation to enable automated driving. So when will automated driving happen? We call it really in 3 steps. We'll start with partially automated. It's really here today. In fact, I would argue that automated driving started with ABS brakes, through electronic stability control, through adaptive cruise control. It was all step by step towards what eventually will be full autonomy. But we'll start with the automated driving, partially automated. It's stop and go up to 30 kph, for example. By 2020, we call it highly automated. That's a little bit more broad use of automation. It's more stop and go on highway, on-ramp to off-ramp. Pretty simple driving tasks when you consider some of the pictures and the videos you saw, right? And then fully automated. That's more highway driving, higher speeds, more complex situations. But even in 2025, when we say fully automated, you notice we don't use the word autonomous, because you saw those scenarios that were presented very well in some of the videos. There's challenges that are really difficult to overcome. So that's kind of the roadmap that we see towards automated driving. That's what motivates us every day. So as we've been working on automated driving, we've tried to enable this technology from a supplier perspective. And we started back in the mid-2000s. We actually participated in the 2007 DARPA Challenge that was referred to many times. We partnered with Carnegie Mellon. We were also partnered with General Motors, Caterpillar, and Continental. It was a phenomenal experience. It was a robotic vehicle. You can see it here. It's nothing you'd like to see driving around the roads. You'll notice it was also an SUV, just like other vehicles that you saw, because it took that amount of storage to house the computers that were required. But a huge learning experience, and we ended up winning with Carnegie Mellon. So it was a nice experience, but it really started our path. And we decided that in 2012, we needed to take that more to the public roads. We needed to take it in a way that was not a robotic vehicle, but more like a production vehicle, with sensors that more or less existed at the time. So in 2012, we were the first supplier to get automated driver's license. We started our cross-country tour, and we gained an awful lot of experience on our production sensors. Then in 2014, we introduced our second generation vehicle. And the main difference is redundancy. We realized through all the testing that you have to have more redundancy. Without redundancy, you will not have safe mobility when it comes to automated driving. And this year we started now our 9 field operational vehicles. We are testing on 3 continents. We are learning the differences between the road signs, the traffic patterns, the people, the gestures, all of the complications that you saw. And we've got about 90,000 miles that we put on these vehicles. So we're learning a lot. But we also have a lot further to go. And there's 3 technology challenges, which I'd like to briefly mention, that have come out of the testing so far. The first is HMI. As the driver engages and disengages from the driving task, which will happen as we go down this automated driving path, it has to be clean, it has to be clear, it has to be crisp. You can't hand the driving task back to a driver without telling them why and what action you expect them to take. So the HMI challenges are huge. We're working extensively on these. The second is sensors. And these are sensors not just in the vehicle, but also environmental sensors and other sensors that will allow automated driving with the information from the cloud, information from the environment around the vehicle. And the third main area is connectivity. Without connectivity to the cloud, without knowing what's going on further than the vehicle can see, we will never be successful with automated driving. So the connectivity is important. But it's not just those 3 technical challenges. There's also an awful lot more that we have to do as an industry. First is the network providers. We need reliable, low-cost content in and out of the vehicle. And it can't just be in the urban environments, it has to be in the rural environments. We need to have an insurance industry that begins to understand the life-saving potential of these technologies, and it begins to give credit and acknowledgement for the benefits that we're going to see. OEMs, we have to find a way to work between the OEMs with the OEMs as an industry. You saw the different names that exist. That's a big challenge because people don't understand what one technology can do versus another. And as you go down this roadmap, people will be confused. So we have to work together with the OEMs. The regulators, it's clear. They have a way to go in this. But I really like the guidelines that were put out. It wasn't mandated. It wasn't regulated. It wasn't spec'd out so that we couldn't enable the technology development that will happen. So I really like the way the regulators are working with the industry to enable this because they clearly see the life-saving benefits. The consumers I'm going to talk more about, but they have to be part of it. They have to realize what the technology can do and what it can't do. Automotive suppliers like Continental, we play a big role, and we have to help develop the standards. Not everyone can develop autonomous driving or automated driving vehicles. We have to have standards, and we have to collaborate. Content suppliers, as these vehicles become more automated, there'll be more content in and out of the vehicle. And that's going to be a big part of providing that comfortable transportation and the better utilization of the time. And finally, the semiconductor industry. The processing power that's required. We can't have computer banks like you saw in the back of the vehicles. We have to have much better processing power, cheaper, and also efficient processing power. So let me focus for a few minutes on the consumers, because the consumers, we think, is one of the big elements of getting to the highly automated and fully automated. So from a consumer perspective, there was a couple studies that have been done. We did our own mobility study in 2015. There was recently a Kelley Blue Book study and also an Automotive News study. And it's pretty scary when you look at it. People say, hey, 63% said, hey, with automated driving, we think the roads would be safer. But 61% say they're scared. 62% are favorable towards the benefits. But 52% are worried about the reliability. 49% are willing to give up control. I could take that the opposite. 51% say that they really don't know whether or not they're willing to give up the control. And 80% always want the option to drive themselves. People are afraid that they're not going to be able to enjoy their car. And I didn't talk so much about it, but fun driving is important. People still want to have fun. 73% say it's the next big thing, but only 60% really even understand and have knowledge about what the technology is. So we have a long way to go with the consumer. That's why we believe that there will be a step-by-step. People have to become more comfortable with the technology. They have to see it, they have to use it, and it's a bit of an experiential technology. So we think it's going to be a step-by-step approach. And we also think that to enable that consumer learning, there needs to be more communication, which is exactly why we announced in January of this year, 2025 AD. 2025, because that's when we think we'll have fully automated driving. And it's a communication platform that we launched. It's intended to be a communication platform for all constituents. Anyone that has an interest in automated driving can add content. It's the media, it's the OEMs, it's the suppliers, it's government, it's insurance, and it's the consumer. And we've gotten feedback, even from some of the OEMs who are saying this is their go-to platform. They can put statements out, they can put ideas out, they can put thoughts out, and get feedback. So we think it's a valuable tool. It's growing, and I would encourage each of you, take a few minutes, go to this portal, learn more, add content, and continue to enable that discussion, because we all need it. We believe that at some point, people won't drive down the road and see a car that nobody's in and say, oh my gosh, there's nobody driving the car. We believe that someday when you see somebody driving the car, you'll be a little bit more scared. So with that, thank you very much.
Thanks, Jeff. Our final speaker for the opening session is Mike O'Brien, Vice President of Product Planning for Hyundai America. A 30-year industry veteran, Mike rejoined Hyundai in 2010 after 14 years with Toyota. He also has held senior positions with Nissan and Ford. At Hyundai, Mike is working to implement various ADAS and connected vehicle technologies. on the company's road to full autonomy. Hyundai led the industry last year in integrating smartphones into the car. More recently, it added compatibility with Amazon Echo's Alexa system, which allows you to access various vehicle features from your home. And I know there's more to come, so let's welcome Mike to the stage.
Good morning, everybody. And Jeff made a very nice transition for me. You know that until we sell a vehicle, nothing happens, and until our customers say they love our vehicles, then not another sale happens. So, you know, it's all about the customer. So let's talk about what we're doing. We're a challenger brand. And so as a challenger brand, let me see if I can go back here. I'm doing this incorrectly already. As a challenger brand, we don't survive by doing good enough. We don't survive by being competitive or by being even a little better than our competitors. We'll only survive as a challenger brand by doing a lot more than our competitors. And we have to do that in a way that catches our customers' attention and keeps them as customers. So when you think about it, we've had to do a number of things over the years to try and really leapfrog the automobile as the way customers see it today. All the way back in 2009, we were the very first manufacturer to delete the six-cylinder engine from the mid-size car. So for decades, the six-cylinder, the V6 was the standard for a mid-size car. We turned all that extra space into a full-size EPA interior. So we were the first mid-size car with a full-size EPA interior. And so we've been doing things like that over the years to try and offer something that's much more than our competitors, and in a way that customers notice and find a way to love us in the future. So you can look down this list, you can see things like the first CO2 sensor. One of our engineers discovered that CO2 presence in the cabin is a leading contributor to driver drowsiness. So we were the first to add an automatic CO2 alert, telling the customer they should be alerted to the drowsy driving condition. We're the first manufacturer to offer augmented reality owner's guide, the first manufacturer to offer a tablet-based owner's guide app, the first manufacturer to offer a lifetime warranty for batteries in our hybrid and our plug-in hybrid vehicles, knowing that a key resistance point for buying electrified vehicles is battery life. So we tried to overcome that with a lifetime warranty. And it's not just about the vehicle itself, it's about what happens while you shop for the vehicle, what happens while you own the vehicle, and what happens when you want to think about replacing that vehicle in the future. So we designed things around the vehicle ownership experience to give customers something that they would remember and cherish when they think about buying another vehicle. Our BlueLink connected services are among the best in the industry, and we'll talk about that in a little while. We're the only manufacturer that offers 5 years of roadside assistance along with the price of your car. We offer America's Best Warranty. We've been offering that for over a dozen years, and we still hold the title to America's Best Warranty. And we're doing that to make sure our customers come back. Back in 2008, we offered job loss protection. If you lost your job and bought a Hyundai vehicle, we would take it back and give you your full purchase price back. We also offered, when we realized customers were concerned about the trade-in value of their vehicle, we offered them a trade-in value assurance. So we offered things that were over and above the basic proposition of buying and owning a car, things that would help you in your overall ownership experience. And all these things are going to be really fundamental building blocks as we move into autonomy, and we'll talk more about that in a minute. Another thing that people talk about, you know, as an anti in the automotive industry is safety. So we couldn't be just as safe as our competitors and survive as a challenger brand. We had to be better. So we have a number of models, our IIHS top safety pick. We're the first non-luxury brand with standard front airbags. This was years ago. We have 6 models today with automatic emergency braking. So we've done things to go beyond what other manufacturers are doing in terms of standardizing and making available technologies that will become fundamental building blocks for autonomous driving in the future. And in terms of quality, we've tried to go beyond by achieving a number of J.D. Power Initial Quality Survey awards. We've just recently won the new J.D. Power Tech Experience Award on 2 models, our new Tucson, as well as our new luxury division product, the Genesis G80. And we just won an award recently, Awards 10 Best for user experience, again, based on that electronics and connectivity experience that our customers are asking for. But as I mentioned a moment ago, it goes beyond the vehicle. It's also outside the vehicle. So many manufacturers have a good connectivity platform. For us, we've recently brought the entire platform in-house, understanding the risks of cyber security as well as privacy. So now we've internalized all of the operations for our BlueLink platform, and we'll talk more about that in a minute. We've expanded its capability well beyond things like remote start, vehicle health reports, stolen vehicle recovery, and things of that nature. We're going well beyond that now. And we've expanded our smartphone apps to include a smartwatch app. So now we've expanded it to include wearable devices as well. And we're among the first to do so. We were the first to bring Android Auto into a car. We're among the first as well with Apple CarPlay. And when you think about autonomy, this is going to be a key enabler. So when people in the future are in their car, instead of driving, they're going to want to be doing other things. So now we've created this portal to bring your home connectivity experience into the car. It allows customers to be much more productive or entertained at their choice. So these are, again, all fundamental building blocks for what we see as autonomy coming forward. Ioniq, which will launch in about 2.5 months, will be the first vehicle that will have one dedicated platform offering 3 electrified powertrains. And remember, when we're thinking about autonomy, it's of course about safety, and it's also about efficiency, how we use our time. But efficiency also is about reduced carbon. So when we think about autonomy, it's going to be a very strong focus on electrification, as we heard with Qualcomm and others, that this electrification will be coming hand in hand with autonomy. And so Ioniq is a dedicated platform vehicle, the first one ever to offer 3 electrified powertrains, so the customer can choose how much efficiency and electrification they want, whether it's pure electric, a plug-in hybrid, or a hybrid electric vehicle. And these will also be offered with a lifetime battery warranty to make sure that there's no concern about the durability of the car over long periods of time. So with that, I'm going to show you a little video about moving connectivity outside of the smartphone and watch space and moving it into your home. So with that, let's start this video.
Come on, Frankie, let's go. What's the matter? Don't you want to go outside? Alexa, how hot is it right now?
The current temperature is 106 degrees.
No, that's not my dog. So it's really all about how do we have a seamless integration of all of our experiences in our lives, whether it's work, it's home, it's through our smartphone. How do we bring all that together and make it enabled through autonomous driving? When we talk about our eco-vehicle lineup that's coming in the future, we're going to have 14 alternative fuel vehicles by 2020. So that's only a few years away, since we'll be launching 2018 vehicles in the not too distant future here, just in a few months. We'll have 5 hybrid models, 4 plug-ins, 4 EVs, and a fuel cell vehicle under the Hyundai brand. And with Ioniq, it's all about taking customers' expectations beyond what they think of when they think of electrified vehicles. Let's face it, for most of us, we think of an electrified vehicle and we think it's just small, probably underpowered, probably not very exciting to drive. And so our target with Ioniq is to make it an exciting car, a very competitive and outstanding compact car, not just an outstanding electrified vehicle. So again, Ioniq gives our customers choice in terms of what electrification they want and how much efficiency they want to get in their lives. So for autonomous, for us, it begins with ADAS, or advanced driver-assisted technologies. So we know today that we use those sensors to observe the environment and control some functions. With our Genesis division that we just recently launched, our luxury division, we offer all these ADAS features as standard equipment across all the models. And with many of our Hyundai models, we're now beginning to standardize. We're working very quickly to standardize and make them available as quickly as we can. So we already have 5 Hyundai models with SAE Level 2 automation available today. So we're moving very quickly into bringing things like lane assist, AEB, and other technologies into the car as fast as possible to allow the bridge to autonomy to occur more quickly in terms of bringing the technologies into the vehicle. In terms of the future, between 2019 and 2021, we imagine we're going to have, by that time, standardized most of these functions. Of course, we've signed the agreement with many other manufacturers to bring AEB standard into the vehicle by 2022. However, we're going to have that done long before that period of time, many years, as a matter of fact. We already have it standard on all of our Genesis luxury models. We'll soon be working towards standardization in our Hyundai models. We'll be working towards highway autonomous driving in the 2019 and 21 period with both longitudinal and lateral control. We'll launch with our Genesis models first and then follow with Hyundai models. We'll have full range collision avoidance with cross-traffic collision avoidance and advanced lateral collision avoidance in the same time frame. Like other manufacturers, Hyundai stepped up early on to participate in the CAMP, the Crash Avoidance Metrics Partnership Initiative. We had focused on addressing vehicle challenges along with NHTSA and the other manufacturers involved. And of course, the focus was on V2X, not just vehicle to vehicle, but vehicle to pedestrian, vehicle to infrastructure, trying to understand how we solve those problems with this crowded city environment. And we're working beyond that as well. In terms of the regulatory environment, as a manufacturer, actually we're quite happy with the agreement that's recently been reached with NHTSA on the guidelines that have been found following the SAE guidelines. For us, it provides a framework for development and testing. It provides us clarification in terms of our goals and our engineering targets as we're setting right now. With state policy changes, it's even afforded us better availability for testing and development. And of course, as we heard earlier, Columbus and Ann Arbor now are at the forefront of this and will be active in this area as well. In terms of our internal focus in our R&D centers, both here in Ann Arbor as well as in Namyang in South Korea, our focuses are very simple. In terms of autonomous driving capability, develop internal capabilities first. We're going to partner where necessary. For example, we've recently announced a few months ago a partnership with Cisco to build very strong computing and connectivity power between our vehicle and infrastructure as well as other vehicles. So we're trying to get ahead of this in terms of computing power and connectivity through the pipe. In terms of connected mobility hub, that's going to be a big priority for our engineering folks. We want to focus on a mobile data hub with strong computing power, as I mentioned, and that's leveraged with our Cisco agreement. We're aimed at making interaction between car and the surroundings much smarter and providing data and security management services for vehicles. So we've had a very, very strong focus on that. I'll mention that again in a moment in terms of preserving security as well as privacy in all of this data exchanges going between the driver and the vehicle and infrastructure. In terms of smart traffic technologies, another focus area for us in terms of reducing congestion and speed up journeys and minimize social costs. And then remote maintenance, and we'll talk about that again in another minute. It allows us to remotely diagnose and many times download fixes to these vehicles so we can handle maintenance tasks without actually bringing a vehicle into a retail outlet. And many times before even the customer realizes there is a problem. So we already have a fleet of autonomous vehicles running at our main global R&D center in Namyang, South Korea. So right now we have 5 vehicles in daily operation. I think the area covers about 1.35 million square meters. And basically it's very simple the way it works. Anybody that works in our R&D facility, that's about 10,000 employees, about 8,500 engineers work in that facility. Anybody that's in that facility using their smartphone can hail one of these autonomous vehicles. And they basically hail it by saying where they're at, where they want to be picked up, and where they want to be dropped off. So the vehicle then, of course, is dispatched to that location. The customer, of course, rides in the vehicle. At this present time, we've had these in operation since about June or July, actually July. We have a person collecting data, human, in the vehicle, but they're not interacting with the vehicle. And so those hands you see in that picture are actually our data collector. And of course, they're ensuring that there's no malfunction as well. So anyway, the customer, or the employee in this case, rides to their destination, and then the vehicle is dispatched to its next pickup. So those vehicles have been running for a while. You'll see them very soon on US roads. I can't tell you exactly when, but we'll say weeks. You'll see them weeks here on this road, on our roads here in the United States. Right now, these vehicles are at SAE level 4. We're using solid state LiDAR like many others, smart cruise control with radar. We also have in this vehicle AEB for reverse. So when the vehicle sees objects behind, we'll also apply auto emergency braking in both forward and reverse directions. So we have stereo cameras, of course, and other technologies that we all know about to enable this level 4 SAE autonomy for these vehicles. We also have another project going on. Similar to the CAMP project, we've aligned ourselves with a Seoul National University. And we have Dr. S.J. Lee, who's heading up Project Ionic for us. So he has 10 full-time researchers and 10 part-time assistants, along with a board that are working on solutions to all the problems we've heard about this morning. How do these autonomous vehicles blend with commercial vehicles that are manned? How do they blend in an urban environment? How do we optimize their capability in terms of efficiency and carbon reduction? And so it's all about trying to imagine all the things that have to happen along with the technology that we've been spending a lot of time this morning talking about. So we've been spending our time talking about how do we make the vehicle autonomous. This group, the Project Ionic group, is working on how to make our society ready for autonomous vehicles and how to allow them to integrate into a city environment as well as a highway environment. One of the most important things we're thinking about here right now is our retail operations. So we have about 837 retail operators, and right now our dealers sell cars, right? They sell cars, they service cars. In the future, you could easily imagine a big shift in what they do. In the future, they could be a mobile hub. So in the future, I may lease access to a vehicle. I may lease access, whether it's 1,000 miles a week or 500 hours a month. I choose my lease plan, and I could lease any number of vehicles, whether it's an SUV or a small car, depending on my usage condition. And these vehicles could be stored at our retail operations, and the retail operation could manage them and store them similar to a lease, but remotely stored in this autonomous environment. And the vehicles are dispatched based on the owner's wants and needs. On the other hand, in the autonomous world, vehicles won't need to schedule service like they do today. These vehicles could self-dispatch themselves at nighttime. So our service operations won't be daytime operations. They'll be nighttime operations in the future. So along with offering our customers access to a number of vehicles, along with offering our customers solutions to parking and storage, we also offer them a no-hassle service solution as well, getting your car serviced at night when you're sleeping. So these are all ideas at this point, but you can imagine in an autonomous world, there's going to be a tremendous transformation in our retail operations and probably the service industry as well. When you think about how our vehicles need to be cared for and how they can be stored and optimized in terms of usefulness. Another thing that's been a big change point in our company, most big companies are set up so they have an IT division. And of course, the sales division handles all the IT that faces the dealerships. And the marketing division handles all the IT that's outward facing, whether it's web space and so forth. And then the R&D folks handle IT relative to the vehicle itself. Well, we decided that's not a way to progress quickly. None of these folks are all silos. They don't talk well together. So we've now consolidated all of our IT under one group. So vehicle IT, in-vehicle IT is in this group. Dealer-facing IT is within this group. Customer-facing IT, which should be through the web, for example, or through your smartphone or your smartwatch, all through this group. Enterprise IT through this group. So now we have the ability to make quick decisions and manage all these issues regarding autonomy under one roof. And so it's allowing us now much better speed and efficiency in terms of making the choices we need to make to allow our vehicles to be enabled, both on the connectivity side, understanding the privacy and security issues that are coming with it, but also on all these extra capabilities that will come with the vehicle when we can bring so much more content in the vehicle, as was mentioned earlier today. So there's much more going on in this space. It's allowed us to really leverage a lot of this IT capability we've had that was separately and fractionalized before, now bring it together under one roof. So just a quick summary. As many of us know, the path to autonomous vehicles is not a one-shot jump. It's going to be many, many incremental steps. And as a pilot, I could tell you the handoff process alone is going to be a very, very difficult challenge that we have to work on together, is how we hand off between autonomous driving and then a person piloting the vehicle. Understanding the impact of these autonomous vehicles on our mobility, society, and automotive business is very critical. The business side I just mentioned, you can imagine there's going to be a sea change on the business side in terms of vehicle maintenance, ownership, sale, and service. Technology must allow data communication with retailers, not just vehicle to vehicle and vehicle to infrastructure, but vehicle to our retail outlets as well as our customers directly. So it's going to be a much different scenario in terms of connectivity in the future. We're going to have to partner with many others. As we mentioned in the room, this is not going to be something one manufacturer can do on their own or one supplier, but we're going to have to collaborate and partner as necessary, and it's going to involve a lot of partnerships and a lot of collaboration to get this done. In summary, our approach to technology is to work at as fast a pace as we can. Of course, as a challenger brand, we have the need to do that, to stay much further ahead than the leaders in the industry. And we have to make sure that we have a robust quality product at the same time, along with a strong customer focus. As I said in the beginning, without the customers, none of this is going to happen. And that's all I have for today.